Okay, just going to go through a couple of examples now. So I'm taking this first example from exercise 2. So we'll go through BaO2, barium oxide. So just looking there at rule number 1, that doesn't apply to us here because we have got no free elements. So these are two different elements bonded together. The sum of the oxidation numbers in a molecule is 0. That one does apply to us here. This is a molecule. We have no charge up here. So when we add up the oxidation numbers of barium and the oxygens, they need to equal 0. Rule 3 doesn't apply. We don't have a simple ion. Rule 4 doesn't apply. We don't have a complex ion. We've got a molecule, like we said for rule 2. Number 5 does not apply. We've got no hydrogens in this substance, but rule 6 does. We do have an oxygen. So just looking quickly, we know that in compounds containing oxygen, the oxidation number is -2. And looking at our two examples, this is not a peroxide, and this is not involving a fluorine. So therefore, we can go ahead and we can say that our two oxygens, I've got two oxygens here, and both of those are going to be -2. -2 and -2. Now, barium, therefore, just based on rule 2 up there, barium is going to have an oxidation number that cancels these two oxygens out. Overall, we need all of this to add up to 0. So barium is going to have to be +4. So there's no rule for barium. It's not an alkali metal, it's not an alkaline earth metal, and it's not a halogen. So we just have to work that out ourselves there. If we know that the oxygens are going to be -2, barium must cancel that out. Next one I'll go through is also from exercise 2. We'll just go through some individual ones before we approach any equation. So let's look there at the carbonate ion. So we've got CO3 2-. So again, no free elements here. Rule 1 does not apply. This is not a molecule, so rule 2 doesn't apply. We don't have a simple ion, so rule 3 is not the one to go for. What we do have is, for rule number 4, we have a complex ion. This is a complex ion. So we know, based on the charge of this complex ion, that when we add up our oxidation numbers for our substance, for our complex ion, they should equal -2. So it should give us equal to -2. So within that then, I've got to work with my 1 carbon and my 3 oxygens that I'm given. Rule 5, so we are working with rule number 4 there. Rule 5, we're not, there's no hydrogen. Rule 6, we are, there's an oxygen. This is not a peroxide and there's no fluorine, so oxygens are going to be -2. And then if we look at the rest of our rules, there's no rule for carbon, so we're going to have to work out the oxidation number on carbon with the rules that we already have. And the rules are that we know each oxygen here is -2, and we know that we need all of the oxidation numbers to add up to give -2. So depending on how you're feeling about this, you can say that carbon is equal to X, and you can say X plus the 3 -2's is equal to -2, and you can solve that, or you might just be able to do it quickly in your head, and you will work out that the carbon there, the oxidation number on that is going to be +4. So +4 minus the 6 for the oxygens will give us -2. So that's us done with the carbonate ion. And what I might do is leave it there. Anybody that was having trouble with assigning oxidation numbers, hopefully this quick little video will help. Give them a go again, go back to it, and I'll prepare another video going through a balanced equation, an equation to show them. Thank you.